students, welcome back. Today we will study an interesting topic which is known as production of electricity from solar energy. The sun is the most vast and direct source of energy. The energy obtained from the sun is called solar energy. The upper atmosphere of the earth receives from the sun nearly 1.34 kilojoule of energy per second per square meter, out of which 53% of the energy is absorbed by the atmosphere itself. Only 47% reaches the earth's surface. To obtain electricity from the solar energy, two devices are used. One is a solar cell and second one is a solar power plant. So let's see how solar energy travels to the earth. Energy travels from the sun as particles of light called photons. Photons are packet of energy. Different photons have different energies. Most photons from the sun have energies that fall within the visible spectrum of light, but we cannot see the photons with energies in the infrared or ultraviolet zone. When a photon hits the solar panel, what happens depends on the energy of the photon. Most solar panels are made up of silicon or other elements. This is a silicon atom. Atom has a nucleus made up of neutrons and protons surrounded by electrons. When an electron is hit by a photon with sufficient energy, it absorbs the energy from the photon and is free from the atom. It is then a free electron. The flow of free electron is current electricity. Different types of material require different amounts of energy to free electron. An insulator requires large amount of energy. A semiconductor requires a medium amount of energy, and a conductor requires minimal or low energy to free electrons. Imagine you are an electron. To be free, there is a wall you need to get over. In a conductor, the wall is very short and you easily jump over. In a semiconductor, the wall is higher and you cannot just jump over it. You will need a bouncer to reach the other side. In an insulator, the wall is very high, so you need a bigger bouncer so that you can jump over. So solar panels are made up of semiconducting elements and require medium amount of energy to free electrons. Currently, solar panels cannot use all the photons that are emitted from the sun, but they can use many of them. Long ago, it was discovered that when sunlight falls on a thin layer of selenium, an electric current is produced. Since only 0.6 of the solar energy incident on the selenium could convert it into electricity, so no serious efforts were made to produce electricity from solar energy. So solar energy is made up of semiconductor material which has a conductivity within conductors and insulators. Semiconductor materials are silicon and selenium, gallium, and there are various others. When a semiconductor material is heated, its temperature rises and so the conductivity also increases. Similarly, if we add an impurity to a semiconductor material, then also the conductivity increases. So in this case, we have added some impurity to the semiconductor material. When an impurity is added to the semiconductor material, it's known as doping. And when an impurity is added, it creates a potential difference in between. And whenever a potential difference is created, a voltage is produced. And due to the voltage, a current flows. This is the idea behind solar cell. Single solar cell of 4 centimeter square produces a potential difference of nearly 0.4 to 0.5 volt, due to which current of 60 milliampere can be obtained. To increase the efficiency, a large number of such cells are arranged over large area so they could collect a large amount of solar energy to produce sufficient electricity. Such an arrangement of solar cell is called solar panel. Let me refresh your memory. that whenever light rays incident on a concave mirror, and if the incident ray is traveling parallel to the principal axis, if it's traveling parallel to the principal axis, then after reflection from the concave mirror, it reflects back through the focus. So the second, a solar power plant is a device in which heat energy of the sun is used to generate electricity. The sun rays, after reflection from a large concave reflector, gets concentrated at its focus, as we have studied here. This principle is used in solar power plant. A solar power plant consists of a number of big concave reflectors, at the focus of which there are black painted water pipes, as it is shown here. The reflectors concentrate the heat energy of the sun rays on the pipe, due to which water inside the pipes start boiling and produces steam. The steam thus produced is used to rotate the steam turbine, which drives the generator producing electricity. Such a solar power plant of capacity 50 kilowatt has been installed at Gurgaon in Haryana. So these are the two ways in which solar energy can produce electricity. Now there are some advantages of using solar panel as well as some disadvantages. Let's see. Advantages is they do not require any maintenance. It can last over a long period of time. Their running cost is almost zero. They are most suitable for remote areas where it's isolated and electric power lines cannot be laid. They do not cause any pollution in the environment. The disadvantages, the initial cost of solar panel is sufficiently high. Efficiency of conversion of solar energy to electricity is low. A solar panel produces DC electricity which cannot be directly used for many household purposes. At night, we cannot produce solar energy. So what we can do, the solar energy produced in the daytime can be stored in batteries or in storage so that it can be used in night. So this is how solar energy produces electricity. Thank you for watching this video. If you have any questions, please leave them in the comment section below. And if you like my video, please subscribe to my channel and give a thumbs up.